So here, this presentation goes like this: electrical theory, the atomic structure, next unit of charge, electric current. So let us start from the atomic structure. What is atom? So atoms are, this is composed of three fundamental particles: electrons, protons, and neutrons, arranged in various combinations. So here, electron. So let us define first this electron first. The electron is defined as being negatively charged and revolves around the nucleus of the atom in various concentric paths called orbits. So the branch electronics, the electronics means this is a branch of engineering that deals with the study of electrons under the appliance of externally applied electric or magnetic fields. So therefore, here the electron is defined as being negatively charged and revolves around the nucleus of the atom in various concentric paths called orbits. Once again, I am repeating this one. Similarly, the proton is defined as being positively charged particle. Neutrons are defined as being uncharged or neutral particle. Therefore, protons and neutrons are tightly bound together within the atom's nucleus and are not free to orbit. Shall we move further? The loosely held electrons in the outer shell often break free due to an input of energy such as heat, allowing them to move randomly around through the space in between the various orbits of the atoms. Such loose electrons are called free electrons. And also, an atom that loses an electron in this way is left positively charged, since it now has an excess of protons. Likewise, if more electrons attach themselves to the valence shell, then there are more electrons than protons and the atom becomes negatively charged. Supporting this concept, okay, we shall watch one video.
Possible barely to make out with the most powerful microscopes. Everything that exists in our universe is made of atoms, including you, I, and the device you're watching this on. In fact, there are about 7 billion atoms in your body alone, which is 7 times 10 to the 27 atoms. But what is an atom? In this video, we are going to look at what atoms are made of, and the mass and size of atoms, and the arrangement of electrons. Atoms may be tiny particles themselves, but they are made of even smaller particles called subatomic particles. Atoms consist of a central nucleus that contains protons and neutrons. Protons are positively charged, and neutrons have no charge. This makes the nucleus overall positively charged. Much like how the Sun has planets orbiting it, the nucleus has electrons orbiting. Electrons have a negative charge. Because electrons are negatively charged and the nucleus is positively charged, they are electrostatically attracted to each other, like how gravity ensures attraction between planets and the Sun. So that's the general structure of an atom. What about its mass and size? Protons and neutrons have the same mass, but electrons are so small they weigh almost nothing in comparison to protons and neutrons. In fact, they are around 2,000 times lighter. As a result, the mass of an electron is concentrated at its nucleus. So that's the mass of an atom. Let's talk about its size. One way to describe the size of an atom is its radius. The radius of an atom is the distance from its center, where its nucleus is, to the outermost shell of electrons. The radius of an atom is typically 10 to the power -10 meters, which is very small. So the majority of the mass of an atom is contained in its nucleus. But in terms of size, the nucleus is much smaller than the atom as a whole. In fact, electrons can orbit really far away
let us stop this video and move further. Okay, so next is the unit of charge. The unit of charge is the coulomb. It is represented by the letter C. The symbol of electric charge is Q. So the charge of one electron is given as 1.6 into 10 to the power of minus 19. So 1 coulomb of charge is equal to 1 by 1.6 into 10 to the power of minus 19, or 6.25 into 10 to the power of 18 electrons. Okay. So next we move further to electric current. Electric current is the flow of electric charge in the form of free electrons. So therefore, current is measured by the number of free electrons passing a particular point within a circuit per second. Therefore, the flow of charge per unit second defines the amount of electric current. When the charge moves at the rate of 6.25 into 10 to the power of 18 plus 18 electrons flowing per second, then the value of the current is 1 ampere. This is the same as saying 1 coulomb of charge per second. And also the SI unit, that means the International System of Units of current, is the ampere with letter symbol capital A. A constant current has symbol capital I, while a time varying current has the symbol small I for intensity. Mathematically, we can define the relationship between charge and electric current as I equals to Q by T. So I is in unit is ampere, and charge Q is unit is coulomb, and T for time it is in seconds. And also I equals to average current flowing, Q equals to total charge passing a fixed point, and T time, that means time taken to pass that point. So later, electric current has a direction. Okay, so this direction is associated with it. That means conventional current flow is in the direction of positive charge movement from positive to negative. Electron flow is in the opposite direction from negative to positive. The arrow in a circuit specifies the direction of the positive current flow. Okay. So